In this video, I'll demonstrate the workflow for packaging TDT files into NDX fiber photometry NWB compliant files. Those files can be uploaded directly to the Dandy archive for data sharing. So the first thing we need to do is log in because we will need to sync the latest experimental metadata with our primary data. So first we'll log in, and then we'll log in with the API. We're logged in, and we'll need to first select our notebook and then our experiment. And then this is the data directory that contains all of our primary data and analysis derivatives. And it's going to go through and sync all of the current notebook metadata to our local directory, so everything is up to date. And then we can skip all of the analysis and extraction pages and go directly to NWB Export. So the first section that we're going to encounter is actually an NWB metadata about the experiment. It's really the who, what, and where of the experiment. You can pick your time zone, your institute in which the experiment occurred, experimental description, who ran the experiment. These are going to be separated by semicolons. So when they get packaged into the NWB file, they'll each be separate. And then a list of keywords that, again, will be semicolon separated. The first thing that you're going to see is that it's going to automatically detect which subjects are ready for data sharing. And so these have been data extracted and analyzed. And so you're going to get an indicator of which ones these are done. So the data itself is actually a downloaded file from TDT. It's an example fiber photometry data set. I've just renamed it to essentially match what it needs to from the notebook surgery form. So this is not, this is just example data. So the first thing you can edit is actually the session date. If you wanted to rename the cohort, if you wanted to add a better description, and you can also update the session ID. All of this will be placed into the NWB file. So once you're finished and satisfied with that, you can confirm the session data. The idea here is that when we are using NWB files is that labs tend to reuse equipment. So the way I've designed this app is that you have an equipment set. So this is for the Tejeda lab. And here you have all of the equipment needed in order to properly form a fiber photometry NWB file. So if you click on the fiber cable, it's going to give you the individual parameters for the fiber cable and the LEDs. There's a lot of metadata that you can do. And so when you've gone through and confirmed this, you select confirm equipment for all subjects. And you'll see now that for all subjects, which unfortunately is just one in this example, you have the equipment assigned. So the next thing we need to do is indicate which injection is actually the calcium signal virus. Oftentimes there are more than one fluorescent expressing virus injected into a subject, and so you need to pick one. So for this one, we have Genalia GCamp 7 slow, and then you also have a TD tomato. We're going to obviously pick the calcium signal, and then you can view the data. This data comes directly from a surgery form in lab archives. These are templates that the Tejeda lab developed that meet NWB requirements. So you write them down when you perform the surgeries or the injections, and that data can be automatically packaged together. So you do it once, and then you'll never have to worry about finding it again. That's kind of the idea behind packaging the primary data, the metadata, and the analysis together. You also have the implant data. This is in a separate form, but it knows where it's at. It knows which cohort this is, which subject it's for, so it pulls out the correct one. And we can confirm injection and implant selections. So you have the ability to add commanded voltage series. I don't really understand what's going on with this TDT example data tank file. I don't know how it was acquired. It's a little bit quirky to me, so we're going to go ahead and skip this. But just know that if you can add your commanded voltage series for your calcium and isobestic signal. Oftentimes these are indexed inside of the tank file. If you know how your acquisition settings are set up on Synapse, then you'll be able to input the volts and the frequency of modulation. I will say that for the commanded voltage series, it is going to go in and check the frequency that you enter versus the metadata. So if there is a mismatch, you will be informed. That is just one of the many checks that we have in here. And that is one of the reasons why I'm not really comfortable spoofing it with the example data, is that it will kind of throw an error if it's not correct. All right, so if you don't want to add commanded voltage series, they're completely optional in the NDX fiber photometry NWB extension. So the next one is that we need to tell it which output to use. So I'm just going to give it a throwaway file. So we'll do del5. So this is going to create that directory, and you're going to build NWB files for all subjects. If things go well and everything is cross-checked correctly, and there's no critical metadata missing, it will show you the balloons, and it will actually write the NWB file successfully. So if you see balloons, that's a good sign. So this is really the endpoint of the application. You've essentially extracted, analyzed, and processed all of the data. And the idea is that now that you have everything finished, you have Lab Archives, which is intended to store your metadata somewhat permanently for all your experiments. You can package them all together into a single experience without having to go through hours and hours of digging through lab notebooks and confirming metadata.